So in this exercise, you have two coils, radius r, number of turns n, line carrying current I. Magnitude of the magnetic field at a point on its axis at a distance x from its center is given by this formula. It is known formula. Show that this reduces to the familiar result for field at the center of the coil. So when you put x equal to 0, you will get one formula that we already derived in our discussion. Now this is the main thing. Consider two parallel coaxial circular coil of equal radius r. So both have same radius and number of turns n, same number of turns, carrying equal current, same current, okay, and same direction, and separated by a distance r. So this distance is r. Show that the field on the axis around the midpoint, around means this is the midpoint, nearby. This distance is small, d is very less. Around the midpoint between the coil is uniform over a distance that is small as compared to r. So this distance is small, d is very less compared to r, and is given by this formula. Okay, so we find out what is the magnetic field of coil C at point P, and then we calculate what is the magnetic field of D at point P. Same direction, oh sorry, this is same direction છે અહીંયા મારે ભૂલ પડી છે, yes, same direction છે. Okay, so because of same direction, magnetic field at point P also in same direction. So if you use your right hand thumb rule, so it will be directed right side for both the case, So after finding the magnetic field of C and magnetic field of D, we will add it because they are in the same direction. If current direction opposite, then we have to subtract. પણ અહીંયા એવું નથી, તો આપણે add કરીશું. And one more thing is very important. This D is very less compared to R. કારણ આનો આપણે use કરવાનો થશે. It is mentioned here, nearby. Distance is small compared to R. So magnetic field of coil C at point P is given by, so B is equal to mu 0 n I r square upon 2 r square. Now what is x? So x is distance from the center, so from here to here, અહીંયાથી અહીંયા સુધીનું. તો r by 2 plus d, r by 2 plus d square and then cube root. Okay, so this is the magnetic field of the C. So now we try to simplify this. Mu 0 n I r square upon 2 r square. I break this bracket, so I am getting r square by 4 plus 2xy, so it become rd, 2 will cancel out, plus d square and then 3 by 2 equal to mu 0 ni r square upon 2 r square plus r square by 4, so it become 5 r square by 4, 4 LCM लिए 4 plus 1 5, plus RD plus D square raised to 3 by 2. So now mathematics only, simplification. Mu 0 n I r square upon 2. Now d is small, so we can neglect. So neglecting d square. So I am writing phi r square by 4 plus rd 3 by 2. Neglecting d square. So what we get is equal to mu 0 n I r square divided by 2. Now look at here. I take phi r square by 4 common because I want to use binomial expansion. So I take phi r square by 4 common. But when it is outside, it comes with 3 by 2. So it is 3 by 2. In the bracket 1 plus rd, and we have taken the common, so I have to divide it by phi r square by 4. Okay, I have to divide it by phi r square by 4, and then 3 by 2 is still there. So this is mu 0 and I. Now look at here, this is r square, this is cancelled out to 2. So r cube and 1 r square is cancelled, so r square is cancelled out. Then this is 4, I can write 4 by 5 raised to 3 by 2. Can we write 4 by 5 raised to 3 by 2? This r is there, yes, so it is 2r. It's fine. Then this is going up, so it becomes 1 minus 4, 1 r is cancelled here. So I am getting 4d upon phi r raised to minus 3 by 2. I take as the numerator. So this is 4 by 5 raised to 3 by 2 mu 0 n I upon 2r. Okay. So this is 1 is d is small. So this value is very small compared to 1 because d is very small. Condition is given, no? શરૂઆતમાં લખી એટલે condition છે. જ્યારે નાની value હોય તો we can neglect higher order terms. So I write directly 1 minus 3 by 2 into 4 by 5 d by r. કદાચ યાદ ન હોય તો 1 plus x raised to n then become 1 plus nx. યાદ આવી ગયું છે તમને, binomial expansion. So this is equal to 4 by 5 3 by 2 mu 0 ni upon 2r. So this comes out 1 minus 2 cancel, so 6 by 5. 6 by 5 d by r. So this is because of the coil C. I say this is 1. Still we have exercise for D also. But I give little bit hint what are the changes. So if you do calculation for BD, okay, so here distance from here to here. So R by 2 minus D, instead of plus D I have to take minus D. So if I take minus D over here, first step I write it down, and I r square upon 2 r square plus r by 2 minus d square and then 3 by 2. અહીંયાથી નજીક પડશે, અહીંયાથી દૂર પડશે, કેટલું d જેટલું, તો અહીંયા માઇનસ આવશે. Now you see this changes, તો અહીંયા માઇનસ સાઇન આવી જશે. માઇનસ સાઇન આવી જશે. So there is the minus sign. So RD is with negative sign. This negative sign. So this is also negative sign. So this become positive sign. So only that is the change. બાકીનું બધું એનું એજ રહેવાનું છે. તો હું ત્યાં ડાયરેક્ટ લખી નાખું BD. So what will be my BD? તો કે 4/5 raised to 3/2 mu 0 n I by 2R 1 plus 6/5 d by R. So this is 2. આટલો જ ફેર આવશે. જ્યાં જ્યાં સાઇન બદલવાની છે અહીંયા પ્લસ આવશે તો ત્યાં માઇનસ આવશે, અહીંયા માઇનસ થઈ જશે તો પ્લસ થઈ જશે પ્લસ. So resultant magnetic field at P B is equal to BC plus BD. So if you add it, so again this is common, so I am getting 4/5 raised to 3/2 common, mu 0 ni by 2R is also common. So this will cancel, so you will get 1 plus 1, so it is 2. So again 2 will cancel. So if you find this value, it comes out 0.72 and multiplied it with mu 0 ni by R. Mu 0 ni by R. So this is the magnetic field due to this two coil. હવે જો અહીંયા આગળ કરંટ ડાયરેક્શન ઓપોઝિટ આપેલી હોત, ઓપોઝિટ અહીંયા, તો મારે માઇનસ સબસ્ટ્રેક્શન કરવું પડત. તો સબસ્ટ્રેક્શન જો હું અહીંયા કરત તો આ 1 ટર્મ ઉડી જાત અને આ એડ થઈ જાત. શું થઈ જાત? આ એડ થઈ જાત. તો 2 times 6d/5R આવે. 2 કેન્સલ, 6/5d/R આવે. વધારાનું શું આવે અહીંયા આગળ? 6/5d/R એવું આવે. હવે તમે આ ફિગર બરાબર સમજી લેજો અને આ ડેરિવેશન નેક્સ્ટ સ્ટેપ યુ હેવ ટુ ડિરાઇવ. તમારી જાતે કરવાનું છે. So this is already done. So here you have some questions without calculation. A magnetic field that varies in magnitude from point to point but has a constant direction, that is east to west, is set up in the chamber. A charged particle enters the chamber and travels undeflected along a straight path with constant speed. What can you say about the initial velocity of the particle? So we know that magnetic field deflects the direction. It doesn't change the magnitude. So here it is not deflected means V must be parallel or anti-parallel to B. That is sure. Must be parallel or anti-parallel to B. And it comes out with same magnitude only. So whatever the velocity at which it enters, with same velocity it comes out without deflection and without change in the magnitude. That is the thing. B. A charged particle enters an environment of a strong and non-uniform magnetic field. Here it is non-uniform magnetic field. And varies from point to point both in direction and magnitude. બંને બદલાય છે. And comes out it following a complicated trajectory. Of course, તો direction બદલાય, magnitude બદલાય, એની trajectory complicated થઈ જવાની. જો uniform હોય તો circular થાય. Would its final speed equal to the initial speed if it suffers suffered no collision with environment. This is also very important. તો આપણે ફરીવાર જાણીએ છીએ magnetic field doesn't change the magnitude, it can change the direction. તો અહીંયા સ્પીડની વાત કરેલી છે. કોની વાત કરેલી છે? સ્પીડ. The speed is the magnitude. તો જે સ્પીડથી દાખલ થાય એ સ્પીડથી બહાર આવશે. Yes, answer is yes. Whatever the speed at which it enters, with same speed particle leaves. જો એન્વાયરમેન્ટમાં અથડામણ થતી હોય તો થોડી ઘણી એનર્જીનો લોસ થવાનો હોય, એટલે એ વસ્તુ આખી જુદી છે, પણ અહીંયા કોઈ કોલિઝન થતું નથી. And third one, an electron traveling west to east enters a chamber having a uniform electrostatic field in north to south direction. તો આનું મારે પિક્ચર ડ્રો કરવું પડશે. Uniform electric field in north to south direction. So I write as usual, I draw this picture. This side east, this side west, this side north, and this side south. Okay. Now, what is the direction of electric field? Electric field in north to south. So this is direction of electric field. So this is E. Okay, this is E. Blue line E. And charge enters traveling east to west to east. So electron is entered over here. તો જો પોઝિટિવ ચાર્જ હોય તેને ફોર્સ આ બાજુ લાગે, પણ નેગેટિવ છે એટલે ફોર્સ આ બાજુ લાગશે. સો FE is toward north. FE toward the north. Okay. Then specify the direction in which a uniform magnetic field should be set up to prevent the electron from deflecting from its path. એટલે ઇલેક્ટ્રોન આમ ઘસડાતો હોય એને મારે બંધ કરવો છે, સીધો મોકલવો છે, તો એને ફોર્સ કેવું લગાડવું પડે? મેગ્નેટિક ફોર્સ. કઈ બાજુ લગાડવું પડે? સાઉથમાં. તો FM ની ડાયરેક્શન સાઉથમાં છે. તો હું અહીંયા આગળ જ્યોમેટ્રીનો યુઝ કરી લઉં છું, સોરી કોઓર્ડિનેટ સિસ્ટમનો યુઝ કરી લઉં. This is X, this is Y and this is Z. તો મારી વેલોસિટી કઈ બાજુ છે? આપણી ફોર્મ્યુલા હું લખી નાખું, F is equal to minus E V cross B. ઓકે, તો ઈઝી પડે. એટલે જો માઇનસ E V કઈ ડિરેક્શનમાં છે? વેસ્ટ ટુ ઈસ્ટ છે, એટલે કે I. B કઈ ડિરેક્શનમાં છે? મને નથી ખબર. અને F કઈ ડિરેક્શનમાં જોઈએ છે મારે? મારે જોઈએ છે માઇનસ કે ડિરેક્શનમાં. So this minus minus cancel. So this becomes plus E I cross. I ની સાથે શું મલ્ટીપલ કરીએ તો કે આવે? તો J તો આવવું જોઈએ. J માઇનસ કે પ્લસ? I cross J is K. So magnetic field must be in downward direction માં. આ શું બતાવે છે? કે magnetic field must be in downward direction. તો આવું થાય. જો અહીંયા ચાર્જ મારો કયો હોત? પોઝિટિવ ચાર્જ હોત તો અહીંયા નેગેટિવ સાઇન ના આવે, તો મારે માઇનસ જે કરવું પડે તો અપર ડાયરેક્શન આવે. અન્ડરસ્ટુડ? ઓકે. Then an electron emitted by an heated cathode and accelerated through a potential difference 2 kilovolt enters a region with uniform magnetic field 0.5 Tesla. So voltage આપેલા છે 2 kV means 2000 volt. Accelerate કરવા માટે. Field is 0.15 Tesla. Determine the trajectory of the electron if the field is transverse to its initial velocity. Transverse to initial velocity and makes an angle 30 degree with initial velocity. So you have two situations are given. Okay. So because of particle is accelerated under the potential difference, it acquires certain velocity. It acquires certain velocity. So how we can find the velocity first of all? So we have one formula, QV is equal to half mv square. Okay, and therefore V is equal to QV upon m. 2 is going here and root of this. So we put the value. What is this? 2 1.6 into 10 raised to minus 19. Potential is 2000 divided by mass of the electron, that is 9.1 into 10 raised to minus 31. So velocity we comes out to be 2.65 into 10 raised to 7 meter per second. So this is the velocity of the electron. Now in case 1 or A, here V is perpendicular, transversely perpendicular to B. So theta equal to 90 degree, right? Therefore, electron moves in circular path with radius r is equal to what? याद करो, mv upon qb. सेंट्रीपेटल सेंट्रीफ्यूगल फोर्स નો આપણે કમ્પેરિઝન કરીને રેડિયસ લઈ આવ્યા હતા, mv square upon r is equal to qvb. So if we put all this value, 9.1 into 10 raised to minus 31 into velocity, we calculated 2.65 into 10 raised to 7, and then it divided by charge 1.6 into 10 raised to minus 19 into magnetic field B is 0.15 ટેસ્લા. તો તમને એવું થતું હોય કે નેગેટિવ સાઇન કેમ નથી યુઝ કરતા? તો અહીંયા આપણે રેડિયસ કેલ્ક્યુલેટ કરવાની, ડાયરેક્શન નથી કેલ્ક્યુલેટ કરવાની. જ્યારે ડાયરેક્શનની વાત હોય ત્યારે પોઝિટિવ નેગેટિવ કન્સિડર કરવું જોઈએ. So this comes out to be 10 raised to minus 3 meter and it is 1 millimeter. So this is the radius. Okay. Now in case 2, second case માં શું કહે છે? It makes an angle 30 degree. So here theta is equal to 30 degree. Okay, so V has two components. V perpendicular is equal to V sin theta. So 2.65 into 10 raised to 7 sin 30, I write directly half. So this is 1.33 into 10 raised to 7 meter per second. So this will determine the radius. And what is the V parallel? So V cos theta, V cos theta 2.65 into 10 raised to 7 into root 3 by 2 sin 30, cos 30 is root 30, cos 30 is equal to root 3 by 2. So if you simplify, it comes out to be 2.3 into 10 raised to 7 meter per second. So this will determine the radius, and because of this it moves parallel to magnetic field, okay, without change in this value. So what is the radius now? So radius is equal to mv perpendicular upon qb. So we put all this value, તો તમે આ જો હાફ જ આવી જશે, તો mv sin 30 upon QB. તો કે half of first one. કેટલું હતું પહેલું? તો 1 mm. So it becomes 0.5 mm. And also suppose question asks, તો આવી રીતે થશે, this is the magnetic field. Okay. In first case, it is moving going directly here in first case, and in second case, it goes like this. So this is V parallel and this is V perpendicular. તો આને કારણે શું થશે? આવી રીતે મોશન કરશે. તો આને કહેવાય છે pitch, as I told you earlier also. So if you want to find out pitch, I can calculate pitch also. So pitch is equal to V parallel into periodic time. So V parallel into periodic time is 2 pi m upon QB. So you put all this value, you will get the pitch. તમને વર્ક આપું છું. Okay.